Welcome to AP Physics Podcast. This is Chapter 13, Homework Number 1. We are well on our way into gravity. We have astronauts on the way to the moon. They reach a point where the moon's gravitational pull is stronger than the Earth's gravitational pull, and first we're asked to determine the distance that this occurs at. So if we take a look at a little diagram, here's the Earth, and maybe here's the moon. They're going to be somewhere in between, and in your book you're given this distance between the Earth and the moon, and that is 3.84 times 10 to the 8th meters. And we're going to find some distance here, and it might be halfway in between. More than likely it's going to be closer to the moon than it will to the Earth. I'll call this distance here from the Earth RE, and this distance here from the moon RM. Okay, so we know right off the bat that RE plus RM is going to equal this 3.84 times 10 to the 8th. Okay, we have a segment, and these are the two parts of the segment. So at the point where the moon's gravitational pull becomes stronger than the Earth's, we know then that the acceleration due to gravity from the Earth will be equal to the acceleration due to gravity from the moon. So what that means in realistic terms is that g times mass of the Earth divided by what I'm calling RE squared, that's going to equal g times the mass of the moon divided by what I called RM squared. When you solve that equation, we can solve it for one or the other. I solved it in this case for RM. We end up getting that RM is equal to RE times the square root of the ratio of the masses, MM over ME. Both of these numbers are given to you in your textbook. Mass of the moon is 7.36 times 10 to the 22nd, and mass of the Earth, that is our 5.98 times 10 to the 24th. So we end up getting that this value is approximately equal to RE divided by just about 9.01. Okay, so we have that equal to RM, and now we can take this and plug it in right over here. So we end up getting that RE times 1 plus 1 over 9.01 is going to equal 3.84 times 10 to the 8th. So we end up getting that the distance that we are from the Earth, which is a good thing to know since that's what the question is asking, ends up being 3.46 times 10 to the 8th meters. All right, for part B, we're looking for the acceleration due to gravity at that point. Well, that one's pretty straightforward. We're looking for g, Earth, at that point in time, which is going to be g times the mass of the Earth divided by what we called RE squared. So you plug all those things in, 6.67 times 10 to the negative 11th, multiplying that by our mass of the Earth, which is 5.98 times 10 to the 24th, and we'll divide that by our 3.46 times 10 to the 8th, all of that denominator squared. So that gives us a very, very small gravitational pull, 3.34 times 10 to the negative 3rd meters per second squared, and that will be directed toward Earth. So we shouldn't feel too bad that the moon overpowered us there, because that is a pretty small acceleration due to gravity. This is question number 11 from AP Physics, Chapter 13, Homework Number 1.